Today, we're diving into the physics of your everyday life. We're talking about how things heat up, how they cool down, and most importantly, how we can get a handle on that constant flow of energy.
I mean, you've probably wondered about this, right? It seems like a pretty simple question, but the answer? Well, the answer reveals a fundamental rule about how our entire universe works. It's not magic, it's this constant, invisible river of energy that's happening all around us, all the time. So here's the plan. We're going to uncover that one simple rule that governs everything. Then we'll meet the 3 secret agents responsible for all this heating and cooling. And finally, we'll see how we can actually master them in the real world. All right, let's start with that one big idea. The single law that governs every hot cup of coffee, every melting ice cube, and honestly, pretty much everything else. You see, the universe is always trying to find balance. It's always pushing towards this state called thermal equilibrium. It's basically the point where 2 things reach the exact same temperature. And once that happens, that big flow of energy between them just stops. Everything is in balance. And here is the most crucial part of that rule. Energy always, and I mean without a single exception, flows from a hotter object to a cooler one. It's a one-way street. Your hot coffee gives its energy away to the cooler air around it. And that now slightly warmer air gives its energy to your cold ice lolly, making it melt. The flow is always from hot to cold. Okay, time to meet our first agent of heat transfer. This one works through direct contact. Think of it like a line of falling dominoes. And we call it conduction. See, at the microscopic level, it's all about tiny particles bumping into each other. It's this energetic little chain reaction, where energy gets passed down the line from one particle to the next. So just imagine this. You heat one end of, say, a metal rod. The particles at that end just go wild. They start vibrating like crazy and jostling their neighbors. Those neighbors then start vibrating faster and bump into their neighbors, and on it goes. And this process works best in solids, where all the particles are packed in nice and tight together. And this is exactly why some materials feel hot almost instantly, while others don't. Metals, they're fantastic conductors. Their particles pass that energy along incredibly fast. But then you have materials like plastic, wood, or even just air. They're what we call insulators. They're just terrible at passing that energy along. And that, as we're about to see, is actually super useful.
Okay, on to our second agent. This one is responsible for, well, everything from boiling a kettle of water to the formation of massive wind currents across the planet. And this is convection. Now this is different. With conduction, the particles just kind of vibrate in place. But with convection, the particles themselves actually move around, carrying their energy with them. Now the key thing here is that it only happens in fluids. And in physics, fluid just means anything that can flow. So we're talking about both liquids and gases.
So here's how it works. When you heat the bottom of a pot of water, that water expands and gets less dense. And because it's now lighter than the cool water above it, it rises up. But then, of course, the cooler, denser water has to sink down to take its place at the bottom, where it gets heated. This whole thing creates this amazing circular flow, a convection current, that very efficiently spreads the heat through the entire pot.
All right, time for our third and final agent. And this one is really special. It's how you can feel the warmth of a fire from all the way across the room. And it's how the sun heats our entire planet.
We're talking about radiation, and it's not about particles bumping or flowing. Nope, this is pure energy, traveling as an invisible wave, kind of like light or radio waves. To be specific, we're talking about infrared radiation.
And get this, here's the really wild part. Radiation doesn't need any particles to travel. It can move right through the total, complete emptiness of space. That's its superpower. And believe it or not, every single object, including you, right now, is constantly sending out this radiation. The hotter you are, the more you radiate. Okay, so we've met the team. Conduction, convection, and radiation. Now for the really fun part. How in the world do we stop them?
This is basically our cheat sheet. To stop conduction, that domino effect, you use an insulator, something like plastic or even just trapped air. To stop convection, that circulating flow, you have to physically stop the fluid from moving, like putting a lid on a pot. And to stop radiation, you just reflect it away with shiny surfaces, kind of like a mirror.
So let's put this all together and see it in action. Think about a regular insulated coffee cup. How does it actually keep your drink piping hot for hours?
Well, it's actually a brilliant 3-pronged attack. First, a lot of them have a vacuum between the inner and outer walls. No particles means you stop both conduction and convection dead in their tracks. Then, the lid stops convection by trapping the hot air and steam. And finally, that shiny interior, it reflects the heat radiation right back into your coffee. It's like a little fortress against heat loss.
Okay, quick pop quiz for you. Based on what we've just learned, you're at the stove cooking. Which pan handle do you grab?
The plastic one, of course. The metal pan itself is a great conductor. That's what you need for cooking food. But the plastic handle is an insulator, and it's designed specifically to stop that heat from conducting all the way to your hand.
And this same logic applies on a much, much bigger scale. Our homes are basically just giant insulated cups. Double-glazed windows, they trap a layer of air to fight conduction and convection. That fluffy insulation in your walls does the exact same thing. It traps pockets of air. Some even have a foil backing to reflect radiation. It's all the same physics at work.
So the next time you feel your coffee cooling down, just remember what's really going on. It's not about creating cold. It's about this constant movement of energy. The real challenge and the real opportunity is in mastering that flow. And that matters because when we master that flow, we build more efficient homes, we design better technology, and we waste a whole lot less of our planet's precious energy. It's a fundamental force of the universe, and it's happening right now all around you.